So welcome everyone. This very problem is from the University of Benin under real analysis math 212. So I'm going to solve it right now. So just focus to know how the solution is achieved. Now, we are given a function f of x and it is continuous at x equal to 4. Given that epsilon, a small positive number, is equal to 0.1. We are asked to find the value of delta for which the function is continuous at this, given this very condition. Delta here represents a small positive change. In the definition of the limit of a function, we have that the modulus of f of x minus f of a is less than epsilon, and also 0 is less than the modulus of x minus a, and this is less than delta. Delta then represents a small positive change. Epsilon represents a small positive real number. Now, I'm going to make sure the first guy, that's f of x, the modulus of f of x minus f of a, less than epsilon. Take note, f of a here is the limit of f of x. In this case, a here will be equal to x, and that is equal to 4. So to get the limit of this function, just substitute the value of x, which is 4, into this expression to get this root 2x plus 4 at plus 1. Sorry, at x equal to 4, that is 2 times 4 plus 1. This is equal to root 9, and this is equal to 3. So the limit of this very function at x equal to 4 is what? 3. So f of a is 3. So f of x is root 2x plus 1, then minus f of a is what? 3. Less than epsilon is 0.1. 0.1. So having done this, I will say root 2x plus 1 minus 3 is either equal to 0.1 or root 2x plus 1 is minus 3 is equal to negative 0.1. So I'll solve for the values of x. So this is root 2x plus 1 is equal to 0.1 plus 3. Collecting like terms. So root 2x plus 1 is equal to 0.1 plus 3 is 3.1. So to evaluate this, I'm going to take the square of both sides so as to eliminate the square root. And taking the square of both sides, 2x plus 1 will be equal to 3.1 squared, 9.61. So let's solve for x. 2x is equal to 9.61 minus 1. And this will give us 8.61. So x will be equal to 8.61 over 2. This is equal to 4.305. So this is the first value of x. Now let's get the second value of x. Root 2x plus 1 is equal to negative 0.1 plus 3. Negative 3 crosses and turns to positive. So root, this is actually equal to minus 0.1 plus 3 is 3 minus 0.1, and that will give us 2.9. 2.9. So root 2x plus 1 is equal to 2.9. I'm going to take the square of both sides right now to eliminate the square root. So taking the square of this left hand side, I will have 2x plus 1, as the square will remove the square root. And the square of 2.9 is 8.41. 8.41. So 2x is equal to 8.41 minus 1. That's by collecting like terms. And this will give us 7.41. So x is equal to 7.41 all over 2. And this is equal to 3.705. So the two values of x here are 4.305 and 3.705. Having gotten these two values, remember in the definition of limit I said 0 is less than the modulus of x minus a, and the modulus of x minus a is less than delta. So what we're interested in is this very interval. So we're interested in the modulus of x minus a less than delta. So first of all, when x is 4.305, let's see what the value of delta will be. X is 4.305. The modulus of 4.305 minus a. A is 4. What would this be? 4.305 minus 4 is 0.305. And the modulus of 0.305 is still 0.305. Okay. What about when x is 3.705? 3.705 minus a, which is 4, the modulus of this difference. Let's see what it will produce. 3.705 minus 4 is what? Modulus of minus 0.295. And the modulus of this very negative small number is 0.295. So these are the two values for delta. Now, the value for delta here, which I asked to calculate for, is the minimum of this 0.305 and 0.295. So, which of these two values is smaller? Actually, 0.295 is smaller than 0.305. So, the value for delta will be this. The minimum is of these two numbers is 0.295. So this is the value of delta. And in this option, in that very year this question was asked, it was option D as the correct answer. So this is actually the solution to this problem of limits under reanalysis math 212. Subscribe, like, turn on notifications, and tell your friends about this channel. Share this very video so that your friends can also learn this, how to solve problems like this under limit. I'll see you in my next video. Subscribe.